Hi, welcome to Learning Monkey. I am Raghu here. In this class, we'll discuss about different types of graphs. In our last class, we discussed some basics on graphs. Please watch that class and come back here. The link for the playlist is provided in the description below. Coming to today's class, the first one is this is very easy to understand null graph. Let's take the definition graph that contains only isolated vertices. What is meant by isolated vertices? In our last class we discussed that isolated vertices means the degree of the vertices is 0, means there is no edge to those vertices. Then we call it as isolated vertices. If all the vertices are isolated, then we say it as a null graph, or simply edges are 0, number of edges available, then we say it as null graph. Example v1, v2, v3, v4, no edges are there, that's why it is a null graph. Coming to the next one, complete graph. When we say it as a complete graph, every vertex in a graph should connect to every other vertex. So you take a vertex v1, it should connect to every other vertex in the graph. Means it should have an edge to every other vertices in the graph, or we can say it as a edge between any pair of vertices. You take any pair of vertices, you should have an edge. With example, you are going to get clarity. Let's take this example. The first one, we are having two vertices. You take any two vertices, you should have an edge. Yes, there is an edge between A and B. Similarly, take this one. This is a complete graph. A, B, C, we are having three vertices. You take any pair of vertices, A, B, edge is there, A, C, edge is there, B, C, edge is there. So any pair of vertices, you should have an edge. Then we say it as complete graph. Or you take A, it is connected to all the other vertices. You take C, it is connected to all the other vertices. You take B, it is connected to all the other vertices. Anyhow, you can understand. The third example is A, B, C, D, 4 vertices are there. You take any pair of vertices, A, C, edge is there, B, D, edge is there, A, D, A, B, A, C, like that. Any pair of vertices, you are having an edge. Then we say it as complete graph. Similarly, the next example is regular graph. What's that mean? All vertices should have the same degree. Then we say it as regular graph. You take any vertex, it should have the same degree. Any degree it should be, but the same one you should have. So example, A, B, C. You take C. What is the degree of C? We discussed it in a previous class. What is the degree of C? 2. B, what is the degree? 2. A, what is the degree? 2. All the vertices having the same degree. Then we say it as regular graph. Similarly, the next example is cyclic graph. A graph n greater than or equal to 3 vertices means it should have at least 3 vertices, then only you can form cycles. Otherwise, we cannot form cycle. A graph n greater than or equal to 3 vertices is a cyclic graph. When we are going to say it as cyclic graph, if it is having vertices v1, v2, so on up to vn, n vertices are there, and those vertices should have edges like this. Edges should be like this. v1, v2 should have an edge. v2, v3 should have an edge. v4, v5, so on up to vn, v1 should have an edge. If it follows this, then only we call it a cyclic graph. Easily understandable by looking at the example. If it forms a cycle, then we say it as cyclic graph. v1, v2, v2, v3, v3, v1 forming a cycle. v1, v2, v2, v3, v3, v4, v4, v1. It's a cyclic graph. But the thing is, here you have to understand, we have to remember, cyclic graphs are given like this. C3 means default it is a cyclic graph of vertices 3. C4 means a cyclic graph of vertices 4. Similarly, C5 means a cyclic graph of vertices 5. v1, v2, v3, v4, v5, v1. Similarly, C6 means 6 vertices. C7 means 7 vertices. So in the exams also they are going to give you a graph is there, and a graph C5 is there. What's that mean? C5 means a cyclic graph of 5 vertices. Exams also follow the same terminology. Now coming to the wheel graph. When we say it as a wheel graph is obtained. How you are going to obtain? By adding a vertex to a cyclic graph. You take a cyclic graph, you add a vertex to that graph, the new vertices is connected to all the other vertices. Then we say it as a wheel graph. Let's take the example. V1, V2, V3. This is a cyclic graph. For that we need to take one extra vertices. In between we have taken a vertices. This vertices is connected to all the other vertices. Then we say it as a wheel graph. It is given by W3. W means wheel. Similarly, W4. Take a cyclic graph of 4. This is cyclic graph. Add a vertex. This vertex should connect to all the other vertices. Then we say this is a wheel graph, W4. Similarly, W5 with 5 vertices. Now coming to the next one, bipartite graph. So this is bit confusing to understand. G is said to be a graph when we are going to say it as a bipartite graph. Suppose if vertex set, G means graph. Graph is containing set of vertices and set of edges. If vertex set V is divided to two disjoint sets, you are able to divide the vertices in the graph into two disjoint sets. Then we divided that into two disjoint sets V1 and V2 such that every edge connects one vertex in V1 and other vertex from V2. If it follows this condition, then we say it as bipartite graph. With example, you are going to get better understanding. Let's take this graph. This is having 6 vertices V1, V2, V3, V4, V5, V6. These 6 vertices are divided into two disjoint sets. Yes, we divide them into two disjoint sets. V1, V2, V3 is one set. V4, V5, V6 is other set. Why we call them as disjoint sets? V4, V5 there is no edge. V5, V6 there is no edge. V4, V6 there is no edge. Then we say it as disjoint sets. In our first classes we discussed disjoint sets, all those concepts. Second unit in the same playlist, discrete mathematics playlist, we clearly discussed sets and relations. This is disjoint set. This is also two. We divide them into two parts, V1, V2, V3. This is one set, disjoint set. And you take any edge. That edge should be connected between one from this set, other from the other set. So V1, V4. You take this edge, V1, V5. V1 from this set, V5 from the second set. V2, V4. V2, V6. V3, V5. So that's why it is called as bipartite graph. Similarly, the last one, complete bipartite graph. Same as it has to follow the same conditions of bipartite graph, but it has to maintain the concept of a complete graph. We already discussed the concept of complete graph, means each vertex should connect to all the other vertices. Here you have to understand one important point. See, mentioned using, complete bipartite graphs are mentioned like this, KMN. Here what is meant by MN means this is a bipartite graph. This is complete bipartite graph. Why we call it as complete bipartite graph? V1, V2, this is one disjoint set. U1, U2, U3 is another disjoint set. So M, how many vertices? 2. K2. N, how many vertices? 3 vertices. K2, 3. This is how we mention the complete bipartite graph. What do you mean that complete means? You take V1. V1 should have an edge between all the other vertices in U, the second set. V1, U1, V1, U2, V1, U3. Similarly, V2 should have a edge between all the other vertices in the second set. V2 U1, V2 U2, V2 U3. Then this is complete bipartite graph. So hope these are the different types of graphs which we are going to use mostly. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.